Figure A shows how a DC motor is run by a pack of 1.5 dye cells. A disc Y perforated with set of equidistant holes as shown in figure B is fixed perpendicular to the axle of the DC motor. When the disc rotates, light produced by LED passes through the holes and falls on a photodiode P. See figure C. The photodiode circuit shown in figure D generates a voltage V. Part A, identify the component X. Component X is a rheostat. It is a type of variable resistor. Then we can write answer for the part A is rheostat. Part B, how would you change the rotational speed of this coil? By changing current in the circuit by using rheostat. When increasing the resistance of rheostat, current is decreasing. When decreasing the resistance of rheostat, current is increasing. In part C, what is the advantage of having four 1.5 volt cells in parallel? You know that we can generate a current for a long time by using parallel cells. Then we can write current can be drawn for a longer time. If we are using series cells, we can increase the electromotive force, EMF, which means voltage, for the cell, for the battery. And if we are using parallel cells, voltage is constant, but we can get current for a long time. Part D, the disc has 20 holes, and if it produces 5 rotations per second, what is the frequency with which the light beam hits P shown in the figure C? P means photodiode. There are 20 holes. The light of LED is hitting P 20 times per round. 20 times per round. But the corresponding disc is rotated in the speed 5 rotations per second. Then 20 times 5 is the number of times the light beam hits P within 1 second. It means frequency is 100 Hz. Part E, draw a rough sketch to show the voltage V produced by the photodiode circuit shown in the figure varies with time t. Assume that the maximum value of V is 30. V is 3 volts. When the photodiode is open to the light rays, it is generating a voltage 3 volts. Then we can get voltage time graph should be like this. when the light rays are hitting with P, there is a voltage. This value of voltage is 3 volts. Y-axis is voltage in volts with time. So you can draw a graph like this, but it is not practical. Theoretically, we can get a graph like this, a higher value and lower value, but it is not practical. In the exam, they have given marks for this graph and this graph. But if the output of the photodiode circuit is, in the figure is not connected to the input of the circuit shown below, number of turns in the primary and secondary coils in the transformer are 25 and 750 respectively. Assume that the value of capacitance C is very large. Take the Zener voltage V is at 75 volts. Part 1. What type of transformer is used in above circuit? We have to use the number of turns. Then finding the type of transformer. There are two types of transformers. If the number of turns in primary coil is less than secondary coil, it is a step-up transformer. It is a step-up transformer. Now, this transformer has 25 turns in primary coil and 75 turns in secondary coil. Then number of turns in secondary coil is greater than primary coil. It is a step-up transformer. We have to write the step-up. This is part 1. If the number of turns in primary coil is greater than number of turns in secondary coil, it is a step-down transformer. Then part 2. What is the value of the voltage that can be expected across the Zener diode? We can write V2 over V1 equals to N2 over N1. N means number of turns. N2 is number of turns in secondary coil. N1 is number of turns in primary coil. V2 is voltage in secondary coil. V1 is voltage in primary coil. Then voltage in secondary coil is the problem. V2. V1 value is 3 volts. It is this value. 3 equals to number of turns in secondary coil 750 divided by primary coil 25. Now 25 divided by 25, 1, 3, 0. 30 into 3, 90 volts. V2 is 90 volts. But they have given that under this situation, take the Zener diode voltage V set as 75 volts. When using a Zener diode in circuit as reverse bias diode, the Zener diode is not allowed to increase the voltage more than Zener voltage. Therefore, we have to get this value is greater than 75, it is greater than Zener voltage. Therefore, we have to get output voltage as 75 volts. The function of Zener diode is acting as a voltage regulator. Voltage regulator means it is not allowed to increase the voltage than Zener voltage. The output voltage is 90. It is greater than Zener voltage, but Zener diode is controlling the voltage such that output voltage is 75. In part 3, draw a rough sketch to show the output voltage with time indicate the magnitude of voltage on the y-axis. Zener diode is acting as a voltage regulator, and for the corresponding voltage we have obtained in first graph. When the output voltage is decreasing, there is a capacitor in the circuit. Capacitor is discharging and this value is maintaining as a high voltage. It means 3 volts. Therefore, we can get output voltage as a constant value. It is 75 volts. Part G, the student argues that the experiment described above has provides a method to construct a DC to DC voltage converter. Would you agree with this argument? Explain your answer. Yes. We can write the reason. The input voltage 1.5 volts has been increased up to 75 volts. This value also a direct voltage. It is a constant value with time. It means there is a constant value. It means it is a direct current.